Hello, it's Curt Geeting with FLUKE Corporation. I'm the Sales Application Manager for the Northeast. Excited here today to introduce the new FLUKE FEV150 EV charging station test system. This is a complete package. It has the ability to interface to the charger directly through the cable, so it will act like the car, have the ability to test the grounds, verify the control pilot, allow me to see errors, and allow me to document wirelessly and paperlessly with the ability to connect Bluetooth to the TrueTest software from FLUKE. So let's start with turning the FEV150 on. When the instrument powers up, this is the screen we're going to see. It will start out in our test configuration. Below that is settings. Below that is doing a manual control pilot. Below that is troubleshooting the GFCI. And then we get into the settings. So I'm going to start simply by hitting the select button and bringing me into a project. The idea here is we can set up different projects for different type of test scenarios or different customers and be able to see the setup for the device and also the data. Keep in mind this is a wireless tester, so it will download all these and along the test results to software when we're done. I'm just going to go ahead and hit select. We'll bring up the first one here, and we're adding a station. What we're doing here is we're going to try to figure out are we testing one or two connection points? For simplicity's sake, we'll leave it as 1 point. I'm going to come down to the voltage supply. We're going to hit select, and it's going to be the choice is the power of this EV charging station 120 volts, 208, or 240. For demonstration purposes today, I have it hooked up to an EV charging station that plugs into the wall at 120, so I'm going to select that. Then we'd come down to max charge current. This will be a function that actually gets set up in advance based on the delivery capabilities of how much current that charging station can put out. For most cars, again on 120 volt, that's typically a 16 amp system. I'm going to head and select that. And then last but not least, some charging stations actually have a fan, so there's ventilation required. That would be something I would either select or not select. In this case, I don't need it, so we'll go ahead and hit save. So we'll go to settings next, and in settings would be a lot of the background information, things that typically you might want to set one time, things like date and time, but the serial number and all the other information that's required for the instrument, including how long you want it to run before it powers off. These are all my selections on the display, including brightness settings, sounds, factory reset, and product registration. One of the things we're doing at FLUKE, which is kind of nice, is the ability to be able to bring up a QR code on the display of the instrument, and that way with your phone or your mobile device you can register the product with FLUKE, and as we have updates and firmware updates on the product, we are going to notify you on an email and let you know that there's more features we're going to add. So I'm going to go into control pilot settings. And what control pilot settings basically is going to be looking at several things, both the top and the lower voltage display on the instrument itself, and have the ability to be able to see these. Now we can do this two ways. We can do this manually, or we can do this automatically. I'm going to show you what it looks on the manual display, which right now basically we obviously are not outputting anything. We're acting like a car, but we're not actually drawing a charge. So you would see in here a couple things. You'll see the upper and lower limits of the voltage being supplied. You'll see the percent on and off time and the amount of current being drawn. I'm going to go through an automated measurement next to show you what that's going to look like as though you're running an actual test. So one of the first tests that we do is what's called a potential earth test. The idea here is we're going to start this test, and in the course of a 3-second span, I'm going to hold my finger down on the top of this button, and what it's going to allow me to do is set a limit and actually tell me if I have a good ground or not. Right now, because it's lit up green, as you can see on the display, it tells me I have a good ground. How would I know it's not a good ground or it isn't grounded? It would light up with a red X on the display. So the other thing that we can do in auto test is select a connection point. And there's several different tests that we can run here. We can select tripping a GFCI. I'll do a quick test here and run this. And on the charger that I have over here, it actually tripped the GFCI. I'll hit stop. So why is that important? So a GFCI, just like you have in your kitchen or your bathroom, is a way of verifying that the ground fault interrupt works. We need to know this on a charging station because if it doesn't work and there's a fault on the electrical system, there might be potential voltage in or current that could come to the outside jacket of that charging station and would cause possibly a safety or harm to the end customer. So we're going to do the nominal voltage test next, and we're going to go ahead and hit start. and what it's doing across the 3 control pilots. So again, A means you're plugged into the charging station, but it's not delivering anything yet. B means we're actually taking your payment. C means we're actually delivering power. So we're testing the nominal voltage coming into the EV charging station right now. And as you can see, we selected 120 volts and we're seeing 123. That is aligned to, line to neutral. It is running at 60 hertz as well, so all is good. If the voltage was way outside the limits expected, then we would show an error indication if it was a lot lower or a lot higher and put a red X on there and tell you that there's not sufficient voltage coming into the charging station. So the last piece of this is really going to what we call the control pilot, and that's basically a connection between the charging station and this particular device, and we're going to test the different charging states. I'm going to delete that last connection. We're going to run this again. And as you can see, what's going to happen, it's going to show me upper and lower limits of the voltages, which is well within the acceptable range. The PWM, which refers basically to this pulsed rate that's coming out of the charger going to the car, actually represents the amount of current being drawn and the frequency that we're seeing that at. And so that then passed. And that will be a repeatable or a reportable result, that we can download the software as well. So the last piece of this, we're going to the last part of the menu structure, and you see it says True Test Software. I'll go ahead and select that. This is, by the way, a Bluetooth connection. So what we call FLUKE Connect, it's a wireless device. It's going to talk to the software wirelessly. So this would be on a laptop or desktop and have the ability to transmit the data over to the software. And the software itself, the True Test, is the ability to be able to analyze the data, create a report out of the data, and be a database for historical tracking of data and measurements we're taking on the EV charging stations that you're testing. And that really concludes what the FEV150 has the ability to deliver as a tool out in the field.
If you'd like to buy, request a quote, or just want more information, give us a call at 800-517-8431 or visit us at testequipmentdepot.com.